Hello people from the future, welcome to Normalized Nerd. In this video, I'm gonna show you my attempt of building a machine learning model that can detect sarcasms. If you are new to my channel, then please subscribe to my channel and hit the bell icon. I make videos about machine learning and data science regularly. So let's get started. I really hope you got that the title of this video is a sarcasm itself, because sarcasms are notoriously hard to detect. There are two main reasons behind it. The first one is to understand some sentence as sarcasm, we need the context in which the speaker has spoken this statement. And the second point is, in some cases, we don't even bother to give the context. We just make sarcasms from our human experiences that we have gathered over all these years from social interactions. So it will be a really interesting thing to see if my model can learn a tiny percentage of these things. Now, before jumping into the technical details of my model, first I'm gonna show you some of the beautiful results that my model has produced. Now, if you haven't seen any beautiful application of natural language processing before, then prepare yourself for something really cool. For now, assume that this blue box is my NLP model. Inside this box, obviously, I have deep learning and other cool stuffs that I'm gonna explain later. Let me first feed this sentence to our model. You just broke my car window. Great job. Well, obviously, this is a sarcastic remark because if somebody would break my car window, I wouldn't be praising them. I would be mad at them. So, this great job statement is actually a sarcastic remark. Let's see what our model thinks. Well, it guessed it correctly. It is a sarcasm. Okay, try another one. You saved my dog's life. Thanks a million. Now, this time I'm genuinely praising the person because he has saved my dog's life. Let's see what our model thinks. And it guessed it correctly that it is not a sarcasm. The next two examples are my favorite. I want $1 million. In this case, I'm wishing something. This is not necessarily a sarcasm. So I think this should not be treated as sarcasm. Let's see what our model thinks. Well, it says it's not a sarcasm. And in this case, I am stating that I just won $1 million. Well, this is a sarcasm. Just think, if somebody tells you that they have just won $1 million, chances are they are being sarcastic because the probability of winning $1 million is really, really low. And my model thinks that is a sarcasm. Good job, buddy. Okay, so that was really cool. But as I have told earlier, sarcasms are really hard to detect. So my model has also done some really bad mistakes. So now I'm gonna show you some of the not so cool examples. In this case, I'm taking a normal sentence as input. His name is Bob. He is a nice person. So in this sentence, I'm describing a person named Bob. So this is not a sarcasm, right? But my model thinks it's a sarcasm. Bad model. Let me show you another failure. In this case, I am giving the title of this video as the input. Well, I have just explained you why this is a sarcasm, because sarcasms are very hard to detect. They are not easy. So this sentence is a sarcasm. But my model doesn't know anything about detection and machine learning at all. And it gives this. Okay, so I guess that was a fair introduction of my model and the capabilities of my model. Now I'm going to show you how I did this. Let's jump into the code section. First thing first, to proceed with any NLP problem with deep learning, we need to use these tools. So make sure to install these tools if you want to follow this particular code, okay? Now I'm going to show you the data. Well, this is a very popular data set that I found on Kaggle. So this data set contains newspaper headlines, and we have a particular column here named is sarcastic. So if there is a 0 in this column, that indicates that the headline is not sarcastic. If it's 1, then it means that the headline is sarcastic. So there was two different datasets, two versions actually. So I have concatenated them and made a new dataset. And pandas will be very helpful in this case. And after concatenating them, I'm just printing the first 5 rows, okay? Now I'm gonna clean the dataset. As I have told earlier in my previous videos that text data cleaning is a very important step in natural language processing. So here are some common text data cleaning things that you can do, and I have already talked about them in my previous videos, so I'm not gonna go very deeper into it. I'm just gonna show you some of the methods. Well, this method will just remove every link from the dataset. This things will remove every flag or emoji from your data, and after that we are converting everything into lowercase because machine learning models work well if we just provide them smaller case letters instead of capital and smaller mixed. And now we are gonna remove every abbreviation with their full forms because machine learning model doesn't work well with the abbreviations. After that we are removing some punctuations here and some symbols too. After that we are gonna do some further text pre-processing, and here I am using tokenizer function, this word tokenize. Now remember that later I'm gonna use keras tokenizer also, but that will be for different purpose. So here we are again removing every punctuation that might be present in the dataset. Then I am removing everything that is not an alphabet. After that, I'm removing the common stop words from English language. Well, stop word means the words that are very frequent, like to, the. That won't help our machine learning model to learn anything, so it's better to remove them. So after all these things are done, we will be left with a proper, cleaned list of headlines. So I have printed the first 10 headlines also. You won't find any articles or prepositions. You won't find any numbers. And everything has been converted into smaller case letters. Okay. Now let's move on. Okay, so here's a nice little visualization I have done. So here I am making word cloud based on the frequency of the words by taking only those headlines with sarcastic remark associated with them. Okay, so after doing this word cloud thing, I'm getting this. So you can see these big words are very frequent in the sarcastic remarks. Now before jumping into the next section, that is the train test split, I want your attention to this headline. What does it say? Sarcasm is very easy to detect, GloVe plus LSTM. Well, so it is quite clear that I am using here the LSTM. Now I have done previous videos where I have shown you how to use pre-trained models like GLOVE word vectors and how to use them in a recurrent neural network. Well, the main idea behind this approach is to convert our words into numbers, more specifically into vectors containing a fixed dimension. So when we are gonna convert our words into vectors, then we are gonna have a series of vectors instead of a particular sentence. So we have got a sequence of vectors. Now we can pass this sequence to our recurrent neural network because they are very good at learning sequences. This recurrent neural network will gonna produce our prediction. Obviously for the classification task, we need to use a softmax layer after the RNN. So my model will take a text as input, will convert it to a series of vectors, will pass it to RNN. After that it will pass through softmax, and then we are gonna have a number which will tell us the probability of that particular text belonging to sarcasm class or not sarcasm class. Okay, so here comes the train test split. Well, I am using here a validation split of 0.2. That means 20% of our data will be reserved for testing purpose and 80% of data will be used for training. Now the max length parameter is very important in this case. Well, I have found that if we take only 25 words from every headline, then it works really well. You can try experimenting with this and see if you can get better accuracy. Okay, so here is the tokenizer. Remember that it is a Keras tokenizer, and I am using this because it will help me to create the tensors that I'm going to pass to our model. After that, I am fitting this tokenizer on our headlines. Then we are producing our sequences. And after doing that, I am computing the word index. Well, the length of this word index will just be the unique tokens, and the vocabulary will be 1 plus the unique tokens. Why? Suppose we give a new word to our model that is not present in our vocabulary, so it must be represented in some form, right? But if we use a vocab size of the known words only, then how can we associate a new number to that word? So for this purpose we have reserved one space that will represent the unknown word. Okay, here I am padding zeros to those headlines which are not 25 words long, and this function will also cut the words that will come after 25 length for a larger headline, so that we only pass headlines of 25 to our model. And here the sentiments are just the values, zeros and ones. Then we are gonna shuffle them randomly, because obviously to do machine learning we need to get rid of any bias that might contain in our dataset. And after that, I am just assigning these variables, these things, so that I can make the tensors. You can see that this X train pad has the dimension of this and 25. Well, this is just the number of examples in our training set, and this is just the number of example in our test set. Now we need to load our GloVe model, and I'm again telling you that I have done the same thing in my previous videos, so check that video too. So I have previously downloaded the GloVe Twitter model in this directory, so I'm just loading this file from there, and here I'm using 100 dimensional vectors. And after reading these files, we will have this embedding index, which is just a dictionary that will contain the words as keys and its vector representation as the value. You can actually print the vector representation of a word by just using this dictionary, and I will highly recommend you to do that to understand how the things work. Now we are going to build our embedding layer. To do this, we need to first make our embedding matrix. Now the shape of this embedding matrix will be the shape of our vocabulary times our embedding dimension. In our case, it is just 100. Now to build the embedding matrix, there is the logic. It is a fairly simple logic. If the word is present in our vocabulary, then we are just taking its vector representation. Otherwise, we are not changing the zeros. So if some word is not present in our vocabulary, that row will be just 0. So this is the way to build the embedding layer using Keras function embedding. And remember to make this trainable parameter false, because we are using a pre-trained model. We don't want to train it again. After that comes the fun part, that is our recurrent neural network. Now I am using Keras here. The easiest way to build a neural network here is to use this sequential module. After that, I am adding the embedding layer as our first layer to our network. Then I'm adding 64 LSTM recurrent neural networks with a dropout of 0.2 and the recurrent dropout of 0.25. Well, these are just hyperparameters that you can tune to get better results. And this step is very important because here we are dealing with a binary classification problem. That's why we need to use sigmoid function. And the last layer will contain only one node. Then we have to compile our model. As it's a binary classification problem, so I'm using binary cross entropy. The optimizer I'm using is Adam, and the matrix I will monitor is accuracy matrix. Then we can just print the summary of our model, and this is the summary of our model. Now begins the training. This training doesn't take so long, so you can do it without a GPU also. So you can see in the first epoch we have got a validation accuracy of 0.78, which is amazing. And after 25 epochs we have achieved a validation accuracy of 0.88. That's really close to 90%. And you can see that we don't have overfitting yet. So that's a really great sign that our model is learning. Now, if you follow my videos, then you know that I love to visualize stuffs. So here I have written a code for visualizing the training thing. So here is the visualization of training. You can see that both of the validation loss and training loss are decreasing, and there is not a very big overfitting. So you can actually train it for a couple of more epochs also. Okay, so that was the technical details that I used to build a model to detect sarcasms. Now here I have written a small function that you can use to test this model. You can just pass your sentence to this function and it will tell you if this statement is a sarcasm or not. Here are some correct guesses, here are some incorrect guesses. I will highly recommend you to try this model and see how many does this get correct. So that was all for this video, guys. If you like this video, then please share this video with your friends and subscribe to my channel. You can also comment your feedback on this video and some suggestions about my future videos. Stay safe and thanks for watching.